of our energies and skills.
Although we've reached a new age, the age of information, where more people on Earth have access to more information than ever before, what's holding us back from solving these problems? Our old ways of accessing and processing information brought us solutions because the passing of time allowed it, whether we were aware of it or not. We may not have time on our side anymore because of the pressing nature of our problems, but we may have found a most powerful ally, a new way of reasoning. So powerful that we are convinced it is the very logic behind the fabric of our universe. We named it quantum computing. However, the tremendous potential of this tool is not enough if we cannot even begin to grasp it as a society. With this in mind, at Quarks Interactive, our mission is to make learning quantum computing come as easily and naturally as having a good time, and with that, introduce quantum literacy to every single human being. Therefore, we've made Quantum Odyssey, the first video game to make quantum computation fun and accessible to people of all ages, no matter their background. With Quantum Odyssey, the idea of applying quantum reasoning becomes simply a matter of understanding and solving visual puzzles. Play your way through quantum computing. Explore carefully crafted learning modules that will open the doors to this new way of reasoning. Browse through an interactive encyclopedia filled with all the quantum knowledge you'll need. And to top it all, no maths required ever. Be part of the quantum literacy revolution. See you in Quantum Odyssey.
To Quantum Odyssey. This is the first full visual representation of universal quantum computation inside of a video game. In this quick video, we'll be looking over the user interface elements within the game and understand how we can use them. Let's begin with the visual representation of our computation, the computational map, here in the center of the screen. It's composed of the input at the top and the output at the bottom. You see zeros and ones, since a qubit can be either 0 or 1 or both at the same time. The blue ball represents the passing of time within the computation. We can speed it up using the back and forward controls or the left and right keys, as well as pause it by pressing this button or by simply hitting the spacebar key. The blue ball is there so we can see the probabilities of the output. Different changes we'll be making to the computation will result in different outputs, meaning the ball might go somewhere else, or it might go in more than one place at the same time. Below the speed controls, we have buttons for adding or removing qubits and gate slots. We'll get into what those are in a minute. So how can we make changes to the computation? How do we get the blue ball to go somewhere else? First, let's open the circuit configuration screen from this button. The shortcut for opening and closing the screen is the tab key. We have two sections. The one above is an inventory of all the logic gates that can be applied to our quantum computation. We go over what these gates are in our learning modules within the game. For the purpose of this tutorial though, I'll refrain from getting into too much detail. To apply a gate, simply drag and drop it on top of a gate slot attributed to a specific qubit below right here. As you can see, if I hover with the selected gate over a gate slot, the highlight that appears in the computational map indicates where this gate will be positioned within our computation. Also note that the specific qubit is also highlighted with red to let you know which qubit will be affected by the added gate. I'll drop an H gate right here on the first qubit for the sake of this example, so you can see what happens. An H gate splits the qubit into two possible outputs. Since quantum bits can be 1 and 0 at the same time until measured, the computational map shows us a 50-50 scenario. The gate we've just applied will either leave the qubit as it was when it entered the computation, or it will flip it upside down, switching that qubit to 1. See how the blue ball is splitting into two smaller ones, each having 50% of the initial size, ending in two possible outputs. The second qubit suffers no modification since no gate was added to it. Let's go ahead and make this extremely complex because I want to show you something. I'll add a few more gates and gate slots right here. Now you see that the ball can change colors as well. The in-game learning modules do a great job at explaining why this happens. When your computational map gets too big, you can pan around it using the WASD keys. And there we go, these are the basics of Quantum Odyssey. You're now ready to start the learning modules within the game, where you'll begin to explore quantum computation in a completely visual way. From qubits and superposition to complicated quantum algorithms based on quantum interference and entanglement. Everything will be in the game.